Hi everybody, this is Mr. Schultz here with you, one of the 8th grade middle school algebra teachers, and we're just going to do a quick recap of lesson 216 and 217 that you did last week, and just kind of take a second to review some of those concepts because they're pretty key moving forward. I know a bunch of you were map testing last week, so just making sure that that everybody's on the same page here. So let's see what this looks like. So 2 and 6, we started taking our expression mats and comparing them and saying, is this side bigger or is that side larger? And so just kind of looking at that. But quick reminder here of these rules, these legal moves that we've been using. And so our first one is remove zero pairs, and basically that's just where you have a positive and a negative in the same region. So in this example here, in the negative region, you have a positive 1 cube. And you've got a negative 1 cube, so a positive 1 and a negative 1 just makes a 0, and so you can remove those from the mat. So this is called remove zero pairs. You can shorthand that to be RZP, but remove zero pairs. The next one, we're just calling this a flip, and it's basically just moving a tile from one region to the other. You just need to flip it. So in this example, you've got two positives that are in the negative or opposite region. And so if it's really the opposite of a positive, well, that's just a negative. So we're just going to slide that up to the positive region and then flip it over, because the opposite of a negative is, or because the opposite of a positive is a negative. So we're just going to call these negative pieces that are going to be in the positive region. So it can be a good tool to kind of find those zero pairs. The key thing is we're calling those flips, or just flip is great there too. The last thing is actually something that's kind of a combination of those two. It's just kind of a shortcut. If you have the same tiles, so like a positive one and a negative, or a positive and a positive, but they're in different regions, so like the positive region or the negative region, you can remove them. So in this example, you've got a negative 1 in the positive region, and you've got a negative 1 in the negative region. So those two things will cancel out to make a zero pair. And the reason why is because if you take that negative that's in the negative region and you were to flip it up using our last move, well, flipping it up, I need to flip the piece over to be a positive. So now I've got a positive in the positive region and a negative in the positive region. Well, that, as we saw from our first one, our first legal move is creating a zero pair. So that's why this move works, but instead of having to write multiple steps, you can just write the one step there, which is just same pieces in opposite regions will create opposites. So let's take a look at this. We did not do these two problems when you were doing these on your own. So 256E, so this is again from section 2.1.6, and you're looking at 256 letter E and F. I want you to take these two, simplify them down, and decide which side is greater. Is it the left side or is it the right side? And I'll go through it in just a second here. All right, so let's take a look at this. All right, so here we are, and I'm just using the E tool here. So basically, we've got a bunch of different options. We can use the flip method, we can do remove zero pairs, or we can remove the same pieces from opposite regions. Well, I like to do the flip method first. So this is on 256E, and so I've got one negative tile, two negative tiles, three negative tiles on the left side in the positive region, and I've got one positive in the positive region. I've got a positive X and a negative X. And so before I do anything, I like to do the flip method first. So I'm going to take the opposite of what's happening in the lower part of the left region, meaning the opposite part. So I've got a positive X cube, or rectangle, so I'm going to flip that up and then just flip it over. I've got two positive Y's, so I'm going to flip both those up and then flip them over. And I'm going to do the same thing on the right side. So on the right side, I've got one negative cube in the positive and one negative Y in the positive. But then in the negative region, I've got a positive Y, so I'm going to flip that over to be a negative Y into the positive region. I've got a positive X, so I'm going to flip that over and flip the positive 1 over as well. So now what I've got left is I've got a whole bunch of stuff here that I can take a look at and see what I can simplify. So on the left side, I'm going to remove zero pairs next. So I've got a positive X and a negative X. So I'm going to take those and I'm going to remove them off of the mat. And then I am going to do the next thing. So the next thing is I'm going to take the negative 1 and the positive 1. and I'm going to remove those from the left side in the positive region there. And then all that I've got left here is I've got a negative y and a negative x. Or excuse me, I've got two negative y's, one negative x, and two negative 1's, all in the positive region. So nothing else there can be simplified. So on the right side, I'm going to take a look at this again. It looks like I don't have anything again that can be simplified. So I've got a negative x, I've got two negative y's, and I've got two negative 1's. So you might notice here right away that this is the exact same expression, so they have to be equal. But if you didn't, this is where you can do our next legal move that we've talked a little bit about, which is removing the same thing from both sides. This can be modeled by adding the same thing and saying, okay, if I've got a negative x on my left side, and I've got a negative, or if I've got a negative x on my left side, well, to get rid of a negative, I would need to have a positive x so that it is a zero pair. But if I add in a positive x to the left side, I need to add in one positive x to the right side to maintain that balance. And now I'm down to where I've got zero pairs in the x rectangle. So I'm going to remove both of those zero pairs now in the left and right side that I just created by adding that positive 1 to both sides. Then I can do the same thing with my y tiles. So with my y tiles, I'm going to do the same thing. I'm going to add a positive y and a positive y to the right side. So I'm adding 2y. But if I do that on the right side, I also need to do that on the left side region. And that's going to create a whole bunch of zero pairs there. So I'm going to remove all of those y zero pairs and get rid of them. And now it's a little bit easier to see, hey, this is the exact same thing because I've got a negative 2 on the left side and I've got a negative 2 on the right side. This is the same thing. They should be equal. So as far as what I would write then, I would take and I just say that my left side is negative 2, my right side is negative 2, so these two sides would be equal. All right, so we're taking a look at 2-56F. And we're going to start off by doing the flip method. I just like to do the flip method first because then I can just read, or the flip legal move first, because then I can just read the tiles as they lie instead of thinking about the negative region as being the opposite of what I see in the tiles. So in the left side, I've got 4 positive 1's. And those 4 positive 1's, I'm just going to flip all of those up and turn them into negatives. And then I've got a positive x and a negative x. You might see this as a zero pair and just remove it right away. But just to be consistent with the method, I'm going to move that up and change both of those to be a positive and a negative. In the right side, I have got 4 positive 1's. So I'm going to take those 4 positive 1's in the negative region, and I'm going to flip them up and change them to be 4 negatives. I've got 2 negative 1's in the negative region, so I'm going to flip those up and change those to be positives. And then I've got a negative x in the negative region, so I'm going to flip that up and change it to be a positive. So now my next step is I'm going to start to remove zero pairs here. So on the left side, I've got a positive x and a negative x, so I'm just going to take and remove those. And on the left side, I've got a positive 1 and a negative 1. So I'm going to take those two and I'm going to remove that. And I'm going to be left with 2 x's and then 6 negative 1's. So I'm going to be left with 2x minus 6, or 2x plus a negative 6. On the right side, I still have 2 x's, so I'm still just going to leave those alone. But then I've got a bunch of negatives and a bunch of positives, so we're going to make a whole bunch of zero pairs here and then just remove all of them, because all of my 1's will cancel with all of my negative 1's. So in total, I will have 5 positive and 5 negative on the right side. And those are all zero pairs, so I'm going to remove all of them. And I'll just be left with 2x. Now from this point, you might recognize that, hey, the negative 6 is going to, on the left side, is going to be smaller than the plus 0 on the right side. So 2x is canceled. But if you don't notice that, that's okay. In this lesson, we talked about that the way that we can remove stuff that's the same on both sides is just we're going to take the opposite of it. So so I'm going to take and I'm going to add a negative 2x to both sides. So I'm taking and I'm adding a negative 2x to both sides, and so long as you do it to both sides, it should be okay. and now I've got a positive x and a negative x on the left side, so that's a 0 pair. I've got a positive x and a negative x on the right side, so that's a 0 pair, so I can remove it. Now it's really, really obvious here that, that on the left side I've got -6, on the right side I have 0. So the right side is going to be larger because 0 is greater than -6. So that's your recap of lesson 216. In lesson 217, which is our next one, we're basically doing the same thing, but our key thing here is we want to try to transition out of this kind of concrete example of algebra tiles and start to move in how do we write this stuff out so that we can kind of do it a little bit faster. We don't have to have these mats and flipping stuff around and doing this stuff. And then also, how do we follow other people's work? Because on the last one, when you just got down to that -6 is less than 0, well, if you made a mistake, it's hard for you to follow somebody else's work and figure out where they made that mistake. So our goal in this one is how can we write it? So here, they gave us this great example in question 2-65 of Athena, and she was comparing two expression mats that are shown down below in that 265 problem, and then it gave us this table that showed what she wrote as the original expression on the left side and what she wrote as the original expression on the right side, and then just explained how she got there. Then it showed each of her simplifying steps, and our goal was just to figure out what exactly happened here. So taking a look at this, it looks to me like on the left side she took this -x squared, and on the right side on the left side she took this positive x squared, and on the right side there's also an x squared. So she just removed x squared from both sides. So removed x squared from both sides. Then on the next side, then going from the second row down to the third row, it looks like she just did that. She did that flip up method. So we're just going to call this the flip method, which is just where she said I took all these cubes that would be in the negative region, which was inside of the parentheses. So, so subtracting a -2. So the opposite of a -2 is a +2. Subtracting a 4 plus 2x. So the opposite of a +4 is a -4. The opposite of a +2x is a -2x. So she just did the flip method and just got it all into her positive region. Then from here, the next method is where she did combining like terms. So she's combining like terms. This is also where you can be removing 0 pairs too, but it kind of all ends up being the same thing. So in this method, so in this step, she took the +4 on the left side and the +2 on the left side and combined them to be a +6. Then she took the +3x and subtracted 1x, and that's how she came away with 2x. Then same type of thing, she's got a -1 and she's going to take away 4 more. So -1 take away 4 more would be subtracting 5. And then she's got a +4x and she's going to remove 2 more x's. So let me put a box around those. So she's got a +4x and she's going to remove 2 x's. So she'll be left with a +2x. Then on her last step here, it looks like she did what she kind of did in that first step that we did. She removed 2x from both sides. So when she did that, she said subtract 2x from both sides, and so long as you do it to both sides, it should be okay. It should make the same thing. So she'd be left with a +6 and a -5. So therefore, the +6 would be the greater side than a -5. So that's what we talked about in this 217 lesson. So here's what I'm going to have you do. We just did these two problems from lesson 216, which is 256E and F, and we simplified them. Let's actually record the work now and start to show what do those steps look like. So I want you to pause the video and try 256. Try recording it into a table. Just basically make your 2 lines down the page, and then just start to create some kind of table cells there for your left side and your right side. And then try to solve what this looks like, and I'll go through them in just a second here. Okay, let's take a look at them. Okay, so this is where we want to start to record our work. So our first step, just like Athena's, was to record the original expression. So I'm just going to look at the left side in the positive region, and I've got 1, 2, 3 -1 tiles. So I'm just going to write down a -3, and I've got 1 +1 tile. So I'm going to say -3 plus 1, and I've got a +x and the -x. So I'm going to write down +x and -x. Then in the negative region, I've got a positive x, and I've got a 1, 2 y's. Then on the right side, I've got one negative tile in the positive region, and I've got one negative y tile in the positive region. So I'm just going to write both those down. And then I've got in the negative region, I've got a positive y tile, a positive x tile, and a positive 1 tile. And those are all in the negative region there. All in the negative region. So now I'm going to start to do what I did last time. So I like to do that first step of the flip method. So I'm going to take a look at the left side. And just like we did when we solved this before, I'm going to move the positive y and the positive x into the positive region and change them to be negatives because I'm just doing the flip method. Same thing on the right side. The positive y, the positive x, and the positive 1 are all going to move into the positive region and change to be negative numbers, just doing that flip method. Then I'm going to go and I'm going to remove my 0 pairs and combine like terms, but let's do the remove 0 pairs first. So on the left side, I'm going to remove a positive and a negative x, and I'm going to remove a positive and a negative 1. And then I'm just going to combine everything all at the end here. So now I've got a negative 2y, I've got a negative x, and I've got a negative 1, 2. So if you want to write those as plus, a negative y or plus a negative x, you can. I just don't like to write the multiple signs, so I'm just going to write them as all negative signs. Then on the right side, I've got a negative 1, 2y, and I've got a negative 1, 2 of the cubes, and I've got a negative x. So now here's where I wanted to simplify even further. So I'm going to start to add in some numbers to try to simplify this. So I'm trying to flip these tiles here so that they're easier to use. So on the left side, I wanted to go and I wanted to add a positive x. But if I add it to the left side, I need to add it to the right side to maintain that balance. So when I add both of those positive x's, I create those 0 pairs, which is what is making that x go away. And you can see in the math here, or just in the more written language, that makes a little bit more sense. If I'm adding an x and I've got a negative x, well, then there's that 0 pair. And I can do the exact same approach with the y. So I'm going to add a positive 2y to the left side, and I'm going to add a positive 2y to the right side and create 2 sets of 0 pairs there, and I'm just going to remove both of those sets of 0 pairs. And now I'm just left with that negative 2 and negative 2 on the left and the right side, so that can show me how they are equal. So here I am adding in an x, so this is a step right here. I'm just going to draw some lines here so that you can see the table a little bit more cleanly. But here I've added x, and then in this next step, I'm just adding, this is the wrong spot for the line, there it is, I just added 2y to both sides. And so that's where I get that my negative 2 should be equal to negative 2. All right, so let's take a look at 256f here. So on 256f, I'm going to just start off by writing the original expression. So I've got 1, 2 of my positive x's in the positive region. I've got 1, 2, 3 of my negative 1s, and I've got a positive 1. It's all on the left side. Now in the lower half, in the opposite region, I've got a positive x, and I've got a negative x, and I've got 1, 2, 3, 4 of my positive cubes. Then on the right side, I've got a positive x in the positive region, I've got a negative 1 in the positive region, and I've got a positive 3 in the positive region. Then in the opposite region, I've got a negative x, so this is all inside of that parentheses. I've got a positive 4 cubes, and I've got a negative 2 cubes. So when I go through, and I am now going to do the flip method here. So I'm going to start off by flipping. So on the left side, I've got a positive x. I'm going to move that up and flip it. I've got a negative x. I'm going to take that and move it up and flip it. I've got positive 4, so I'm going to take all those up and flip them. Then on the right side, in my opposite region, I've got a negative x. So I'm going to move that up and flip it. And then I've got 4 positives, so I'm going to move all those up and flip them. and I'm going to take my two negatives and I'm going to move those up, and I'm going to flip those as well to be positives. So that was my flip method here. Now I'm going to move into combining like terms / removing zero pairs. So when I first remove zero pairs, on the left side in the positive region, I've got a positive and a negative x, so that's going to go away. And I've got a positive and a negative 1, so that's going to go away. And what I'm going to be left with is I've got 2 positive x's, 1, 2, and I've got 6 negative 1 cubes. So this is just going to be positive 2x, take away 6. On the right side, I have that same positive 2x, and then I'm looking at removing zero pairs here. So I'm just going to line all of these up here and see what's left over, and I've got 5 negative 1s and I've got 5 positive 1s. So I'm just going to take all those because they make all zero pairs, and all I'm left with then on the right side is just 2x, and that's it. So now, this is the step from 2.6.1 that might be a little bit more unfamiliar. But what's happening here is I'm taking these positive x's, and since they're on both sides, I can actually remove them. And so to model removing them, I'm going to add in a negative 2, which you'll see in the algebra here that if I am taking away 2x, well, that's kind of like adding 2 negative x's to both sides. So on the left side, I've got a positive and a negative, which is creating a zero pair. I've got a positive and a negative, which is creating that second zero pair, so I've removed both the x's. Same thing on the right side, positive 2x, negative 2x, removing those creates a zero pair. And now here I am all the way at the end, where my left side is negative 6 and my right side is 0. So my right side has to be bigger because 0 is bigger than negative 6. All right, and that is a whole bunch of everything. Please reach out if you have any questions. We would love to hear from you.